Hi guys, so today we're working on the extra credit problem. So some of the assumptions we've made are that the rope is 150 feet, which is approximately that many meters. The free fall is 130 feet, which is approximately 39 meters. The stiffness is around 270. The mass of an average person is 80 kilograms, and we're 10 feet above the ground, which is about 3 meters. Initially, when Initially, we have potential energy, and at the bottom, where all the potential energy is converted into kinetic energy. So we're going to start with our basic formulas, which is mg delta h is equal to 1/2 mv squared. And then after canceling the n's, we can solve for v, which is approximately 27.87 meters per second. Then we go to finding the tension force, and in order to do that, we have to first find the perpendicular force, which is mv squared over r. Plug in the mass and the velocity found with the total length of the rope to find the F perpendicular, and then add that to the gravitational force to find the tension force, which is approximately 2100 newtons. Then we go to find the length, the velocity when it's 30 degrees from the bottom, and in order to do that, we have to multiply the cosine of 30 by the length of the rope when it's still going down, and then through basic simplification, we can then find the h to be 9.17 meters. And then using that stretch, basically, or how far it goes down more, and we know that at that point, we still have potential energy and kinetic energy, and then we still have the initial potential energy. We cancel out the m's to find the final velocity, add all the stuff in, and then we find the final velocity to be around 24.43 meters per second. Using that velocity and the mass and the total length of the rope, we can find the perpendicular force again, and then adding that to the gravitational force, we can find the new tension force. Then in order to find this stretch, we can use our assumed stiffness with the initial tension that we found when we were at the bottom of the swing. And so after dividing the tension force by Ks, we can find a stretch of 0.794 meters, and then doing the same for the 30-degree angle, and the new tension at the 30-degree angle, we can find the stretch to be 0.387 meters. Now we're going to be going to the Python to see how the swing works. This shows how the jumper first free falls and then goes back up, and it shows that the velocity is greatest as it's reaching the bottom, and it stays like that till then it starts going back up, and the tension is greatest at the bottom as well. And then when increasing the stiffness of the rope so that the stretch is decreased, we see that the trajectory is much more circular, and we can either get that by increasing the stiffness or increasing the mass, or decreasing the mass. And basically that shows that you can change the trajectory based on the stiffness. And the computational values were similar to the analytical values.